We're going to talk about JSON Web Token in this video. Sometimes this is referred to as JWT token or JWT token. They are all the same. So JSON Web Token is normally used in the context of authentication and authorization. So let's first understand how authentication and authorization works without this JSON Web Token, as in by using normal token, and then we'll come back to JSON Web Token and understand how advantageous it is to use it. Okay, so now I have three components here. We have client and we have our server and we have something called identity provider. So for this example, I have chosen to use this identity provider, which is external from the server. It could also be part of the server, but for this particular use case, I have chosen to keep the identity provider as a separate component. Think of this as some sort of SSO that is implemented within your company, which is a separate component or service, or this could even be something like, for example, the OAuth or OpenID kind of an authentication and authorization provider. So that is what we have. And this server, it only allows authenticated and authorized clients to use its services. And also our server trusts this identity provider, meaning if a client is trying to access this server with the authentication token from this identity provider, then it allows that client as long as the client is a valid client and they have enough permissions. Okay, so that is what it means when we say this particular server trusts this identity provider. Okay, so now let's see how this works. Before anything, this client goes and registers with this identity provider. So this client will get some sort of unique ID and it will also have some permissions assigned to this client, right? So we may have different permissions assigned to different clients. And in this case, this particular client will get an unique ID and it will also get some permissions assigned to it. So when it does register, let's go with a simple example. When it does register, it registers with a username and password based authentication. Okay, so now it's all registered, it's all ready now. Now, when this client wants to access the server, what it does is it goes to this identity provider and it submits its username and password. And as long as the username and password provided by this client is a valid client, this identity provider is going to issue a token. Okay, so this token is going to be an opaque token. When we say opaque token, this is a token. It doesn't have any meaning or data in it, except for the fact that this identifies this particular client and this particular authenticated session. Okay, so that is all it means. So that is why we call it as an opaque token. And now we have this opaque token. With this opaque token, our client goes to the server and access one of its services or trying to access one of its services. So it basically passes the token along with its request and it goes to the server, and the server is trying to validate whether this token is a valid token or not. So for that, it needs to access the identity provider, right? It has to go to the identity provider to check whether this token is a valid token first of all, and also it needs to check what kind of permissions this particular client has. So it goes and gets that information. Then once the server made sure that this is a valid token and this particular client has these kind of permissions, it allows and disallows depending on what type of service they are trying to access. If they are accessing one of their permitted services, then it will be allowed. Otherwise, it will not be allowed. So this is a normal setup. So in this setup, the problem is, if you see here, whenever a client submits a token, the server needs to go to the identity provider and verify whether the token is a valid token first. Then it also needs to get all the permissions that this particular client has. Okay, so this means this is kind of a centralized authentication and authorization. Both authentication and authorization happens in a central location, and that is this identity provider. And this may be exactly what you need in many scenarios, and this is how many of the authentication and authorization works. But in some situation, you may not want to go to the identity provider for verification of the token and also getting the permissions of this particular client, right? Think of a scenario where you are trying to access a server and that server doesn't have access to this identity provider because maybe because of the way it is deployed, or this server is a third-party server and we can't allow that server to access our identity provider. So there could be any number of reasons. And if you're in a situation where you have a server and that cannot access identity provider for verification, then this token, this opaque token, will not work. And this is where JSON Web Token is going to help us. Okay, so before going into the details of JSON Web Token, let's first understand some of the terminologies used within JSON Web Token. Okay, within JSON Web Token, we have something called issuer. Okay, and we have another thing called audience, and we have something called subject, and we also have something called claims. Issuer is basically the entity which is issuing this token. In this example, this identity provider is the issuer. Audience is what is the resource we are trying to access with this token. So in our example, our audience is server, because that is the resource we are trying to access with this token. So that is what the audience is. And subject is who this token basically represents. In our case, our client. Client is the entity that this particular token that we are getting from our identity provider represents, right? Because the client submits their username and password to get this token. Now the subject of this token is this client. Then we also have claims. Claims is very important because claims are facts about this authenticated client, right? And it also has facts about the token itself. For example, this will say when this token was issued and when this token is going to expire and things like that. So these are the 4 important things that we need to know about the terminologies used within JSON Web Token. Okay. So now the JSON Web Token is nothing but a string made up of 3 parts. Okay. So this has header, we have payload, and we also have signature. All these 3 parts are separated by dot. Okay, we'll have a dot which is separating these 3 parts. Now both header and payload are nothing but JSON, valid JSON, which was base64 URL encoded. So we'll have a JSON, we'll have some key value pairs here, and we take this and base64 encode this. When we do this, we'll get the base64 version of this particular header. And we do the same with payload as well. So our payload, we have some key value pairs as a JSON message. We do the same. We take that, we do base64 URL encoding, and we get another base64 string, right? So we take those two, we join them together with a dot. So we have a string which is the base64 URL encoded version of our header, and we have another string which is base64 URL encoded version of our payload. We combine these two like a normal string concatenation with a dot. Okay, now we take this header dot payload base64 encoded string, and we actually create our signature from that. Okay, so there are different ways to create signature. We could use simple hashing, we could use encryption as well, and we can also use asymmetric encryption or symmetric encryption. Okay, so let's first start with hashing. Okay, so if you are going to use hashing for creating this signature, what we will do is we'll take these 2 parts, the header dot payload, and we will simply hash it using the hashing key that we have. So for hashing, we need to have a key, and with that key, we'll create the hash of these 2. And we just add it as a third part, which is our signature. Now, this is our JSON Web Token. Okay, so we have header, payload, and signature, and each parts are separated by dot. That is what our JSON Web Token is. If we are using encryption, for example, when we are using symmetric key encryption, it is very similar to our hashing algorithm. We'll use that encryption key for encrypting these 2 parts, and then we will do base64 encoding, because when we do both hashing and also encryption, whatever we get, we need to base64 URL encode that as well. Okay, so that is what our signature is going to be. When we are using asymmetric encryption, again, this is very similar to symmetric encryption, but the signature will be generated using the private key. Okay, so whoever has the private key is the only person who can create this signature Normally, this will be the identity provider. Identity provider will be the only entity that will have access to the private key, and that will be able to generate this private key. Okay, so now we have our signature. Let's understand what happens on the server when we send this JSON Web Token. So the JSON Web Token goes to our server, and the server is going to first validate this token, whether this is a valid token or not. And for validation, it doesn't have to go to the identity provider. All it needs to know is if an hashing algorithm is used for creating the signature, then it just needs to know what hashing key was used so it can verify the token. So what it will do is, in case of hashing, it will take the header and payload part, it will hash it using the hashing key that it has, and it compares whether the hashed message that it gets is matching the one that we have in the signature. If they do match, then it can be sure that the token hasn't been tampered. Okay. Now with hashing, that is all we can do. We can simply check whether the token has been tampered or not. We cannot ensure the issuer of this token, because anyone who has the hashing key can issue this token, right? So in our case, the server has hashing token for verification, but it can also use it for creating different signature as well, right? So it can create another token and it can use that hashing key for creating the signature for that token, and it can pass that around. It may be okay for some scenarios, but in some scenarios you only want one entity to issue the token, and other entities you simply want them to verify the token rather than being able to create their own tokens. Okay, so that is where we are going to rely on asymmetric encryption. With asymmetric encryption, the identity provider creates this token with header, payload and signature, and the signature is created using the private key, and only this identity provider knows that private key, and it passes the token to the client, and the client sends it to server. Now server needs to verify this token. In order for the verification, all it needs to know is it needs to know the public key of the private key used by identity provider. So servers that trusts this identity provider will have a copy of the public key, and it can use that public key to decrypt this signature, because with private key, the identity provider will encrypt the message or encrypt the header and payload, and with the public key, the server is going to decrypt this part, and it is going to compare that with the header and payload. If they match, then it can be sure that the message is not tampered, and also it can be sure that this token has come from this identity provider, because this is the only identity provider which has access to this private key. So simply because of the fact that this was signed using this particular private key, we can be sure that this is coming from this identity provider. Now the server doesn't need to go to identity provider for the verification. What about the permissions that this particular client has? Okay, so now we are going to look at the payload in detail. You can have any number of claims within the payload. Think of it as information about this particular client. It will have this client's username or some sort of user ID, and it can also have all the permissions that this particular client has. Okay, so it can say that this operation is allowed, this operation is not allowed, because if you think about the payload is nothing but a JSON object, right? So it is actually set of key value pairs. You can pass anything within this payload, and that could very well be the permissions of this particular client. Okay, so now the token has gone to server, and the server has verified that this token is a valid token. So for verification, it doesn't have to go to identity provider again. And for the permissions, again, it doesn't have to go to the identity provider, because the payload itself has all the permissions of this particular client. Okay, and remember, this payload cannot be tampered by anyone, including the client. The header and payload was constructed by this identity provider, and with that header and payload, it also attached the signature. So if anyone changes the header and payload, the signature will be different, right? And when the server tries to verify that signature, it will not match, so the whole token will be rejected. So the server now doesn't have to rely on identity provider for both authentication as well as for authorization. Okay, one of the things that you need to remember when we talk about JSON Web Token is that the header and payload information is not a secret. Anyone can view this information. The only thing is they cannot change this. unless they have the private key. Okay, so if you want to pass some secrets around, then using JSON Web Token is not a good idea. Okay, now let's go into one of the website called JWT.io and we will look at how it works on that particular site. Okay, I am here in this website now. This is JWT.io. This website is a great website for learning JWT or JSON Web Token. As you can see here, we have the encoded token here and we have three parts: header, payload and the signature, and these are all nicely color coded here, and we have these parts separated by dot. And if you see here, we have our header, and in this case the header has two JSON properties. First one is algorithm and the second one is type. So because this is JSON Web Token, the type will always be JWT, but the algorithm is going to tell what type of algorithm you are using for signing this token. Okay, for creating the signature part, what type of algorithm that we are using is specified in here. Most of the JSON Web Token header will only have these two. We won't have anything more than these two. Okay, so these are sort of predefined one. The value of the algorithm could be different based on the type of algorithm we are using for signing. And the payload is interesting one because we could put anything here. Whatever we put inside this payload is technically called claims. Okay, so we have this subject and this is some sort of ID for the subject and the name of the subject, and we also have issue date. Issue date is basically a date. It says when this token was issued. So the representation here that we are using is actually a number of milliseconds elapsed since Unix epoch. Unix epoch is actually some date in 1979, I think. So that is the date representation used here. And like we saw previously, if we want to add some permissions for this particular user, in this case John Doe, then we could just add additional JSON properties here. We could say that this user is an admin user. So I can say is admin, and I can also say whether this is true or not. So I'm going to say true in this case. And I'm also going to add one more permission. For example, I'm going to say whether they can send email. Okay, so like this, we can add any number of additional claims for this user. And as long as these claims are understood by the audience of this token, which is basically this server in our example earlier, then it is fine. We can add any number of these claims. Okay, and then we have the signature part. And like I said earlier, we are actually base 64 URL encoding the header, and we are base 64 URL encoding the payload. Then these two parts are combined with a dot, and then depending on the type of algorithm, we'll be having some secret here. If it is a hashing algorithm, we'll actually put our hashing key. If it is asymmetric encryption algorithm, then we will put the private key here for signing and public key here for the verification. So once all of them is done, we'll get this token, and this is the token that we'll be passing around. Okay, so this is the whole token that we'll be passing around, and because this has all three parts separated by dot, anyone can easily parse it and they'll be able to see what is in the header and what is in the body. And as long as they have relevant key for the verification of this token, they'll be able to verify it as well. Okay, this website is a great website for learning more about JSON Web Token. That's all. I'm going to leave you with that. Thank you.